Hello, my name is Mauro Gerbo. I work as a data scientist for Huber and Suhner in Switzerland, and I would like to introduce you to a problem we had regarding SPC, and I would like to have you on the ride. So I want to talk about SPC scripting and why it's important to write information back into a database. So what we have is an optical measurement system that measures dimensions on parts that we store in a database. The goal was now to get the data back out of it and do statistical process control on it. Now, what happened was that over time, some variables can shift, and the worst case would be that we get the out of spec. And then we have to do some measurements to get it back in, but it would be preferable if we can do that beforehand. So the idea of SPC is like telling a dog to stay where it is. So we achieve this by we define a stable phase and say if the process moves out of that window, it gives a notification before it gets an out of spec, and we can take measurements to get back into stable again. So one way to achieve this is by the process screening platform. We can sort about these control chart alarms, which gives us how many of the variables violate the test one. Test one is simply out of spec, out of control limits. But as you can see, the most alarms I get from the most stable process. So this is a bit paradox. As you can see here, I have a very stable process, and the SPC limits that gets calculated automatically gives me very much false positives. So I shouldn't react on this because it's just within the variation. A second problem with it is if I have an order and analyze the samples, it calculates the control limits for me. Like in this example, it says it's all good. If I later on analyze a second order, the calculation of the limits automatically switches to the new process variations. So it makes the window bigger and again says, hey, everything is okay, until we see, of course, that it moved and the variation got bigger. So what I did, making an SPC script that deals with the measurement and loads and stores SPC limit in the database so we can have a proper working SPC. So I would like to switch to the demonstration of how this looks in our database. So what we have is a script that imports the data. What it does is it goes into the database and search all product order we have stored. For this demo, I made a special data set, and it automatically that contains this program. And program for us is like an article or a part. So we can select it like PO1. That's the first one we did. In our example, I can say, okay, I want to have a look at that data and get data back. And this is the final result. So as we can see here, we have the process screening, process capability, and the SPC. In our example, this is what happened. I have a stable process. Everything is good. If I now look at all processes, this is where the error came from. Again, I can show you the SPC. So you see here, beginning, the process was okay. Then there was a phase from where the variation got bigger and then it got back again. But this X1 was the problem. The problem was X2. As you can see here, I got some parts out of spec. So this I would like to change now. So as we discussed earlier, what we need to do is go to the first PO and say, this is the stable one. This is I want to go back to. And I make now run the script that goes over the table that is active and extract every line with a spec limit. So I see here, this is the spec limits, and you can see here empty control limits. So what I can do now is two ways. I can either activate the SPC here, have a look at the data and say, zoom in a bit and say manually on X2 lower control minute 2.98 and 3.02. And then tell the program, hey, please update the limits for me. Voila. And I go back to, no, this was the wrong one, sorry. So 2.97 and 3.01. Update. And the limits I just set are now in the control limits, which I can check in X2. It added the control limits for myself. The problem is now if I close the table and re-download the data, these control limits are lost. So what I can do now is save it, close all, reload the data. And the script now looks if there are control limits present for X2, and I did none for X1. And if I go here now, SPC, X2, the control limits are now set as desired. If I have a lot of control limits present in my dataset, like 20 or so, it could be quite difficult to set the limit manually for everyone. This is where I made the script that you can actually select the desired variables you want, set default. And as I showed you earlier, if I would set it to 1, it would copy the automatic calculated limits from the system, which can be too tight. And in this case, I say, okay, I want the margin twice as big. Said, okay, now it runs through every row and sets automatic the limit. I save the limits to the database. And if I run the limits again, you can see it's centered and it has a nice window around them quite easily. So I can manage limits for a lot of variables. If I go now to the problem we had, so I now select all of them, run the script again, is all POs. And run it again. Now it takes over the limits I set earlier. So as you can see here, I would get warnings earlier on that something is wrong. And then we could have prevented this from happening. And as you can see here, we took some countermeasures, and now we are back again into the stable phase. This is one use. So what I use in the script is I search with spec limits to identify which one are variables to work with. This can also solve problems with platforms who depend on spec limits. So I can filter them and only make limits or control limits for SPC or spec limits for the process capability platform, so I don't get an error message that control limits are missing. What is important is, of course, safety. Habit of JMP is that the source is in the file. So whatever password or database connection you use gets stored into the table. This, of course, can reveal server name or even username and password. To get around this, there's a preference ODB hide connection string. What you also can do is in the script itself, encrypt the code with password and username. You see in here, so people are unable to read it. When I write into the database, I use the code create database connection. I set the reference, and then there is a SQL statement I put together from insert into which database name it is. Then what I write, that's from the list. I generate program name, sample size, and the control limits, and then execute these SQL statements from the connection string and the SQL string. What's important is that when the log is longer, so I get an error message from the SQL, it beeps me and put it in the log. So when everything or something is working wrong, I can check it like credentials are wrong or the connection could build up or whatever it's possible. Then I write the control limits into the data table. So I check for the name of the article and if there are SPC limits present. If they are, I update the column properties with the control limits, which then get automatically displayed in the SPC, and the program handles accordingly. Second use for writing something back is if we have a measurement, we make a test with it, like environmental test or endurance test, and make a second measurement. I have the same part with two measurements. Or I have a false measurement, like something went wrong. I retake the measurements, and the second measurement is actually what counts. So this I can navigate by a small script that says update DB. I can give me a dialog if I want to set the measurements inactive or update it. If I want to update it, I can type which label I want and what's the name of it. It works similar as the function name selection in column. What it does is for each measurement, I get a unique ID, even if the part itself has a serial number. So I have the serial number measured twice after 0 hour, after 100 hour from test option 1, but it got different measurement IDs. This is how I differentiate between the measurements. And for the inactive parts, That's simply that in the SQL statement, I can say if the measurement were inactive, disregard it. So these faulty measurements don't show up. So key points is careful that you may not give out some sensitive information like password usernames. You can hide certain parts in the script to with encryption. The code is JSL encrypted, and then the encrypted code is in here as a text. And use pref ODBC hide connection string. And another way is use Windows authentication to avoid credentials altogether. This also can help that you can use specific columns that are writable, like the label 1, label 2 column, and to avoid manipulations. So we have the policy a user can set a measurement inactive, but he cannot delete it. So if we will search to the database, we can restore all the data if something went wrong. Another good practice is check that the data is actually written into the database, like a handshake, and enrich the data with important information that can be handy for user years later, because they may don't have the information why you took 3 measurements of the same part and maybe wondering why it's getting worse. And in that, all have the same information to work with. I can illustrate this little future view. So I can go back in here for the demo data. So usually when we have graph builder, make it row, it's there in the string, and second 2. What I do is hide this, select those parts, row, name selection in column, and that would give me a column which I then can save. But if I reload the data, this information is lost. What I can do now is this feature, update database. I can update it. I can say, hey, label 1, this is stable. And you can see here, label 1 is now marked as stable. I can go then say, okay, these measurements update. This I want to label on stable. Voila. Close it. And I simply get the data from the database. And as you can see, the stable, unstable phases are stored. And if someone later makes a then they can draw a conclusion from the phases. Here's missing. This is the stable phase. This is the unstable phase. And the same goes with data. I can select some update. Set inactive. He will warn me if I want those 3 inactive, and the next time I would call the function, they wouldn't show up. If I want to have them back, I can select here, include error messages, that those messages come back again. So this suits my script. I will thank you for listening. And if you have further questions, I will be live later on. Thank you very much.